All right. So, first of all, let me welcome you all to our system skill class. Right. This is one of the introductory class into basically, as the name suggests, right, computer system. And today we'll cover the introduction, which is why should I care about the class? How would the class structure look like? Uh, and also, what is the basic of computer, right? So, sorry. All right. So let me begin with the course overview. All right. The Myself, my name is Rashada. So for those of you who might have taken class with me before, if you kind of take class at MUIC in a weird like order, the section one, there's someone from the parallel programming class that then took this class. I'm like, why are you taking the class in that order? Which is kind of weird. But if you have been in my lecture before, oh yeah, I see some name that family. Uh, yeah. So, um, I am a lecturer at KMUTNB. That's where my contract basically สัญญานักเรียนทุนผมต้องไปลงตรงนั้น so basically I'm teaching at TGS is a graduate school focusing on master and PhD degree, but when I was at CMU, I get to know Ajahn Kanat and Ajahn Sansern, so I was helping out with the teaching at MUIC, and I've been enjoying teaching you guys so far. It's been awesome, and you can contact me through this email. That's the main contract with contact whenever you want to email me. You can ping me on Discord. You can find me on whatever channels you want to find me. If I see that, if I can respond, I will try to respond as quickly as possible, right? The office hour for this class is still by appointment. And probably will merge section 2 and 1 office hour. And this will be done on Discord. I will send a poll to schedule an actual hour, right? Uh, right now my plan is probably to be at 4 to 4:30 on one either Tuesday or Thursday. Right now leaning toward Tuesday. I also do have a slot Friday afternoon, so I'll send a poll and see what works for all of you. There's no required textbook for this class, right? Many of the things we learned today and going forward for the course, many of the stuff can be you can find more material on Google. There's multiple like official sites about how to write program in C, how to use Linux, how to use GitHub, and the basic of the computer systems. Uh, if you're curious, like, oh, Ajahn, I want a textbook, right? I can recommend you a few that would cover the topic that we touch in this class, but please treat it as more like a reference material that you can kind of like expand upon, right? Recording for all the lectures will be posted online on YouTube, as I said earlier before we begin the lecture. And it's likely to be online for the whole semester based on the pandemic situation, which doesn't seem to get any better soon. Uh, Again, this depends on the pandemic situation, and my gut feeling is telling me that for this whole semester we'll do online. All right. And here's the course website. If you haven't done so, please go and join the course website. Sign up now. If you have a friend who are not on it, please do so. This will be main source of my communication to all of you regarding this class. Right, regarding this class. Uh, if you have a friend who are not in this meeting and are not enrolled in the class yet, but they enroll in the course officially at MUIC, make sure they sign up for the class because that's how I'm gonna post all the homework, all the lecture materials, all the in-class exercise, and The rest of the discussion will be done on MUIC Discord. So if you don't have the MUIC Discord server yet, the link to the server, then make sure you also join that. We'll do it later in the second half of this class, right? Because we have basically we'll switch over to Discord and make sure you can log into the server so you can work on your assignments, on your labs, also on your in-class exercise. All right. The class is shared across two sections, so you can see the statistics for both sections combined. My curve will be done for both sections combined to make sure they are fair, right? And here's a quick class survey. How many of you programmed in Python before? How many of you do not know how to write a program in Python or Java before? So if you never program, period, right? I would basically suggest you to talk to your main academic advisor and see if this class is for you, because there'll be some material that would require like prior experience in programming, at least in like the basic Python class. Java, if you program in Python before, that's fine. I just want to make sure it's either one of these and you have like, it's not like, I want to make sure this is not the first time you see a program and you have to write a program. That's all, right? If this is like the first time you ever write a program, I'm not sure this is a class that you want to take in the beginning. You might want to start with Python. Right. So how many of you here haven't taken data structure yet? Right? If you took data structure before, or if you are taking it this semester, awesome. If you haven't done so, there will be a part in the C lecture that has a little bit of the data structure involved. If you have not taken data structure class before, let me know when we are going through those material, because I want my cover for the parts that are needed, right? But I need to be let know, because I want to make sure that we use the time accordingly. And if some of the concepts I refer to are not familiar to you, you need to let me know. So that's why I kind of ask this question first. Uh, and how many of you are taking the algorithm class right now? Actually, I think there's a conflict in this slot, right? So if you took it before, some of the concepts you learned in algorithms could translate in some of the program discussion we're doing it in here in this class. Uh, so both data structure and algorithm will help in terms of understanding some of the things we do in C, but it's not required. It's not required. And if I say about something that touch on these topics and you're like, I have no idea what I'm talking about, let me know, because I want mine explaining it for you, right? I want mine explaining it for you. Just let me know. So there's the key thing. Just let me know. If I refer to things you do not know, please tell me. Please tell me. Right? Because I want to make sure we are all making progress and make sure I don't leave anyone behind. It's like, hey, I never heard about this before and you got lost. Like that's the worst thing that can happen, right? I want to make sure if if there are things that need additional explanation, I have that explanation ready for you. And then let me start to then motivate why you should care about computer system, right? So one of the thing I was refer to is many of your course, right, would emphasize on abstraction, right? Even with algorithm class, right, you abstract away things like, okay, memory accesses, you abstract away the cache, right? We're gonna touch a little bit on those topics and see why that can make impact on performance, right? Because these abstraction have limits. Abstraction in Python, right? Python is really programmable. It's actually really easy to program. A lot of the control are being done automatically by Python, right? You don't have to worry about many things that you might have to do in C. Uh, but again, Python also comes with its own trade-off. Sometimes it's being regarded as a little bit slower in terms of performance. So these abstraction impose some limit. For example, if your program has a bug, right? If your program has a bug, knowing what's happening beneath your program, beneath those abstraction can help, right? So knowing how computer systems work can help you fix some of the bugs that are more involved with the computer system side of things. So knowing how computers are being organized, knowing how the OS works, knowing some basic OS commands could help in this case, right? And in the end, if you know how to debug a program, it allows you basically becomes a better programmer, right? You can find bugs easily. You can even write code that are faster, right? There are so many in my own experience, right? When I use app developed by Thai developers, when I compare to apps developed by other countries, I can feel that hey, the things we do are sometimes like really slow compared to other countries' apps, right? You don't want to like basically launch code that are way too slow because the user at some point it was like, hey, I give up on this, it's too slow. And it also like prepare you for the more advanced classes, such as the operating system, computer architecture. Basically, this allow you to kind of it's a gateway into learning how computer works, right? And let me take this phone call. I don't know what's up with like this delivery people that have to keep calling you. So let me take this real quick. All right, and also I guess they can get lost. Uh, So this class is more like an introductory gateway into more advanced classes, knowing how the operating system works, so you can actually build a better OS, right? How many people here would be interested in cloud computing or like build a cloud and allow other people to run things on your cloud? So this is one of the I would say most important topic, right? To know behind this is like a basic building block behind cloud computing. I'm not talking about using the cloud. Being a user of the cloud is easy. Managing the cloud and build the cloud is actually a different story. It's involved like operating system. You need to know distributed system, knowing how each of the server would interface with each other, knowing how to manage the traffic and knowing techniques to make sure they don't crash, right? If how many people here want to try build design chips, like computer parts, chips, memory, design new things? So that's actually an area called computer architecture, which is what I do, right? So I graduated at Carnegie Mellon. My thesis basically involved how to build the GPU, uh, and basically most of the tasks here that we do as a computer architect is, hey, let's look at the new types of program, how to build a faster computer for the user, right? So again, this class, which kind of cover how the computer is organized, right, will give you the basic block for the next class that would teach you on, okay, if you want to start building this hardware, how do you do it? What's the thought process? How do we analyze application and know the demand and know the bottleneck? If you want to run things in parallel, right? You want to make your program faster. This class is also another basic block for parallel programming. OPL here is like what actually is the old class here at MUIC is changed to parallel programming and programming language. I actually this is another class that I typically teach. It will be offered it's offered last semester. It's going to be offered again next semester, and we are going to go through how do ones design a language. What are the properties of the language? What are the properties of the parallel programming, right? So that would kind of give you an overview of how to make a program faster. Again, this class is a building block. It actually also a building block for all the back end technology. I'm talking about the technology itself, not about like knowing the back end, but how to build those things, right? How do you build things that required for people who work on the front back end development of the web application, right? So these things are again the basic building block. This is like a gateway to these topics. And for those of you who don't like this, it can be a gateway to hell, right? And it's not for everyone, right? People have a different affinity to different CS topic, right? For me, I love hardware, I love system, but my silver bullet are things like maths, right? So if I got thrown into like a really complex algorithm, I would probably cry. For some people, they love maths, so like, hey, I want to do algorithm rather than this like system topic or so again I hope throughout this course you learn whether you like this or not, and if you know you like it, you can look into like how to pursue this track, right? This is one of the track in definitely for this country that not that many programmers who know computer systems. I can definitely assure you of that. We are really far behind comparing to other countries in the world. We are way behind. There's way too many people doing like web application, way too many people doing like front end and back end, whatever full stack development, right? There's not enough scientists and engineer that actually built this tool, built the system, built on knowing how to build a large distributed system. And the result of that, in the past year, you've seen many apps went down. Yeah, of course. Also, not many ties in at TSMC. TSMC is also those are more of the circuit design as well. So that's even like lower level than what I do, which is architecture, right? So TSMC would do both architecture and circuit, like digital circuits. How do you put transistor together to actually like kind of minimize the size, minimize the noise, minimize maximize the reliability and make it small, right? Those are also really, really hard things. Um, but yeah, as a result of the lack of enough people who know deeply enough of this topic, you can see how many apps that crash and went on the news in the past year. Do you see that time when people have to get an OTP and DTAC suddenly give the OTP about 1 or 2 days later? Remember that? Those are part of the queuing theory, right? So you can kind of like maybe look into potentially fixing this in the future, right? Many of the bank application that went down, right? It actually has to do with how they manage their distributed system, right? So if you know the amount of resources you have, you know how to actually extrapolate it. Okay, that's going to be a burst of user coming in. How are you going to handle the traffic? How are you going to do the load balancing? How are you going to actually clear out the old job to make sure you can launch the new job, right? These are topics in computer systems. And again, this class is like a gateway to that, right? And here are the material that we will cover now that I've been talking on this slide for a long time. So there'll be 3 modules. The first module is how to use Linux and what are all the useful tools from that you can use to develop your code. The second material will cover how to write program in C. Why C? C is kind of like a program that's really close to the hardware. So many of the things you have to do on a system side, sometimes you have to control the hardware. So it's easy, actually, it's way easier to do that in C compared to doing that in Python. So learning C has its own benefit. And then we'll transition into computer system and organization. You start learning what happens when you run a program. Why does sometimes the program is fast? When you buy a computer, if you read the spec sheet, what happened? Why does something cost more than the other? What are the trade-offs? Right? So once you finish this class, you are going to be able to understand what happened when you run a program, and also so that you can write slides without bugs in them that have the program W. This sentence, I'm ashamed of myself because I think I've seen this same thing about 8 times now throughout the lecture at MUIC, and I haven't have the mental cognition to actually go and fix it somehow. And I always like forget that this thing is gonna be typo. I bet that it will appear next semester. Sorry about that typo. But you should understand what happened when you run a program. You should also understand what might cause a bug, right? Or a severe slowdown that you observe. And be able to make the program run faster, right? So it would cover a few modules, as we said, 3 modules. The first module is on Linux. This will be the first 3 lectures. And you learn how to use Linux, shell scripts, terminal, regular expression, and Git. Regular expression and Git are not exactly a Linux thing, but these are also tools that allow you to work more efficiently, right? So basically, we'll learn how to use tools that allow you to be lazy, and who don't want to be lazy, right? Who don't want their more of their free time that you can use it for something else, right? So these are material that allow you to write scripts, right? Way to automate things. And as a result, you can be a little bit more lazy, have more free time to yourself after you've done all the scripting. Then, now that we covered Linux and how Linux work, we cover how to write scripts so that you can actually automate many of the tasks you have to do. The next module is C. Basically, we'll cover how to code in C, what is a pointer, how to manage data in C, right? And quick note is, in these modules, there might be some instance of be covering things like data structure, right? So if you haven't taken data structure class and you run into those lectures, please let me know, right? Please let me know that, hey, I haven't taken data structure, so I can cover the part that you need to know. Right? I wouldn't mind doing that, and I think I have a way to kind of like basically cover enough material that you understand what's going on, without it being too much or like basically becoming another data structure class. And one quick note is that we're not going to cover C++. If you know C, C++ is basically the object-oriented version of C. Let me get the door because I think the package is here. I'll be right back. All right. I'm so sorry about this. Okay, I'm back. So basically, the second modules, we will not cover C++. If you're curious, uh, if we have time toward the end of the course, we can kind of like do a brief introduction on how to program in C++. But think of it this way: if you program in Java before, this is like a fusion of C and Java. So the object-oriented concept you learn from Java or even Python get morphed into C syntax, essentially. Uh, And C++ is another really, really powerful language. It's really fast. It actually can be done, and it can actually help with like a bunch of system programming. And once we go through that, last module, we're gonna learn how computer system work, the basic of it actually, before you take the next class, which is another required course for your degree. It's called PCSA, or Principle of Computer System and Architecture, which kind of like give you an overview of computer system, computer network, and computer architecture. The kind of like the three main core of the basis of computer hardware and computer system. We will learn how computers store your program, right? When you install a program, what happened? When you run a program, what happened? How does it store the data associated with the program? We'll cover things like data representation and data manipulation. And we'll also cover how to represent data in a binary format. What does a logical operation do? How do you perform each computation in binary versus hexadecimal versus decimal, right? How to add binary number, how to subtract binary number. We also learn x86 assembly. This is one of the most common assembly language in the world, because these are what is used in Intel chips and AMD chips. And generally, we'll cover what is assembly and why assembly, right? You also cover what is going to happen, right? When a program, access the data, and how to make the data access really fast, right? Because at the end of the day, we want faster program. Right? Who wouldn't want that? Either faster program or more power efficiency to your program. How to make data access easier to program, and we'll learn that through a concept called virtual memory, which is another really important topic. It's another abstraction that the computer system gives it to the programmer so that you can program way easily. And I'll try to put tentative schedule on Canvas. But the topic would follow the three modules. This kind of depend on our pace, right? Usually by the end of by the middle of the semester, we'll cover the Linux and C, and then after the first quiz, we will then transition into data representation, assembly, as well as computer system, and then the second quiz come in. And as I said, there are two quizzes. One happens in the middle, and one happens at the end. You can think of it as a midterm and final. This will be done throughout the class. One would cover Linux and C. And at the end, we'll have another quiz that covers data representation and memory hierarchy. And the format of the quiz right now is going to be online, right? It's going to be online take-home exam. I'll give you a day or a little bit more than 1 day to work on it, open everything. And the way I design the question, you should be able to finish it within the class period, right? And sometimes if you take a class with me before, I know that whenever I said that, it's a lie. It's not my intention to lie, but sometimes I make a question that way too hard. Don't worry about that. I curve things, right? So at the end of the day, if it's too hard, I'm gonna curve it. If it's too easy, I will leave the curve alone, right? If it's too easy, I'll get an A. Perfect, it's fine. If it's too hard, I'll make sure I curve the exam. I curve things. And here's the course structure. So yep. Yeah. Yeah, there was a comment that said finish within 2 hours means 20 hours. Again, I'm sorry, that's not my intention. I tend to do that. I this time I have a lot of TA, so I make sure they at least take a look into that. It's like, would that take too much time? So at least feedback from your peers would help me into making it more realistic in 2 or 3 hours to finish the exam. So we have 24 lectures, 4 to 5 assignments, likely 4. It's going to be programming based. You have 2 late tokens in total, and you can use up to 1 per assignment. And if you have late homework, they are not going to be graded, except this is important, except if you are about to fail. If you are about to fail, make sure you finish everything you can finish, despite how late it is. And then submit it to me before the final exam. Before the final exam. In that case, I'll see how can I help to make sure you do not fail. All right. But otherwise, if it's late, they're not going to be graded. So I hope this is another way for you to kind of like recover and still learn, right? I won't just freely pass you in this class. You need to learn. So this is one possible option, and I don't encourage you to go with that option. I would love it to have give an A to all my students. And here are the breakdowns. 40% of the class will be quizzes, the midterm and the final. 50% will be on assignments, 45% from correctness, and the other 5% from your test cases. So make sure you test your own program. And the other 5% is participation. Basically asking questions through the chat, discuss among your peers, making jokes in the chat once in a while based on whatever we are lecturing right now. That's fine, right? I have no requirements on how you want to attend the lecture. If you want to eat snacks, if you want to eat food while you're listening to the lecture, it's fine. Go do it. I won't ask you to turn on the video as long as one thing is true. Make sure if you have questions, if you cannot follow what I'm saying, let me know. That's the only thing I ask of you, right? That's the only thing I ask of you, because I want to make sure if I lose you, I know where and how to recover. So make sure that you follow what we are learning, right? That's probably the most important thing. Otherwise, do whatever you want to make sure you are conscious and awake and learn, right? And then 5% will be in class exercise. So they'll be given toward typically the last 45 to 30 minutes of the class. We have in class exercise. We'll switch over to Discord so that you all can work on your exercise and share your screen. If you run into problems, uh, you can ask questions. Uh, I'll try my best to get back to every single questions, but from what happened in section 1, it turns out this semester there are way more students than previous semester that I go through the system skill class. Sometimes there are like 10 questions happening in parallel, right? So I am human. I have two hands, one head, so I need to process each of the questions sequentially. I'll do my best to address most of the question during this like 30 minutes to 45 minutes after the lecture. All right. And these will be in class exercise. It would help with your homework. It would help with your final. It would help with your midterm. It would help with all the quizzes. I encourage you to work on it. My policy is the deadline for the in-class exercise is the last day of class for every in-class exercise. Treat it as your playground. You can do whatever you want to play with it, learn from it. It doesn't have to be correct solution, but please make sure you submit by the end of our semester before the final period begin. All right. So that's my policy on the in-class exercise. And here's my policy on collaboration. I think it's the same as most classes. I strongly believe in the power of collaboration. I think that we should know how to collaborate, right? There are ways to collaborate that would make sense. That would be a positive thing. Working together is better than working alone, right? So I encourage you to discuss material, discuss how to debug a program. I encourage you to come up with a creative way to kill your own program by testing it and found some edge case that would break your program. So that's totally fine, right? But you must write your own code. This is how you are going to learn, right? This is how you are going to learn. If I suspect that you copy your code from your friends, I can ask you to explain what do you do on your code in a live session. If you cannot answer what you're writing, what you're coding, it probably means that you did not code that part, right? So if that happened, I would be suspicious of you plagiarizing some of your friends' code, right? So, one more thing, when we release the quiz and the final, please don't collaborate. That's just a no-no. That please put a limit on that. That's how you learn, right? And please don't collaborate on this. Uh, you should not share code. No copying, no retyping, no looking at your friend's code, no looking at your friend's monitor or file, or tell your friends how to write things line by line. But also don't copy code from previous course or from the internet. But these are okay. You can discuss high-level design. You can discuss how to use certain tools to debug your code. If you're stuck at certain bugs for a while, you can ask your friends like, "Hey, I'm stuck here. How am I gonna approach debugging this?" So that you can learn how to approach debugging your program. Because at the end of the day, when you graduate, when you go and work, you need to know. I mean, if you want to continue being a computer scientist or computer engineer, right? If you want to be a programmer, you need to know how to debug your own code. So it's okay to discuss these things and know and learn from it and work together to come up with creative test cases that maybe I didn't even think about, right? So these are good. These are actually encouraged. My policy is if I detect you plagiarizing your friends, you're gonna get a negative maximum of your grade, right? So basically your grade will likely go down 1 or 2 letter grades. That's bad, right? So please don't do this. Please don't do this. One more thing, if you have exam conflict, which can happen, right? Please let me know. One thing that can happen, how many of you run into a situation you have like 3 exams in 2 days? If that's going to happen sometime in this semester and one of the exam is my class, let me know ahead of time because I don't mind moving the exam. I want to make sure you are at your best when you work on the exam, right? There's no need for you to kind of cram things over because I am aware that most of your exam are likely to be online, take home, take a long time to finish the exam, right? I don't want to overburden you with tasks that sometimes are impossible to do. So please tell me if you have conflicts so that we can find a good solution for all of you. The key thing here is all of you. Right now, there are 59 people enrolled in this class. So I'll try my best to pick the best date for everyone. But because there are 59 of you, that might not be the optimal day, right? So I'll try my best. This is what I can promise you. I'll try my best. And let me know if you have conflicts so we can uh, basically do the conflict resolution to make sure that we all reach a solution that we are happy about. And here's my expectation. So I would love uh, to for you to ask questions. So there are going to be a lot of new material that we're gonna cover, right? So asking questions is key. If I go through a slide and you're like, I have no idea what you're talking about, I will not mind at all for you to put it on a chat. Say, do you mind explaining the that last slide again, or just say slide number because I don't get it. That's totally okay. That's totally normal, and I actually encourage you to do so. Why? My goal is to make sure you understand what I'm saying, right? And and sometimes things are hard, right? Sometimes things are hard, and sometimes I didn't realize certain topics are harder compared to others when you learn it for the first time. It depends on your own background. It depends on like sometimes it actually even depends on how much coffee I drink before starting the lecture because sometimes I go too fast, right? If I'm going too fast, if something you don't understand, let me know. So that's the only main thing I'm gonna ask of you, except for don't plagiarize your friend's code. So email me, ask question in the lecture is totally fine. Email me with question when you're lost or not sure how to frame the question during the lecture is also fine. I'll try my best to address all these questions. right? I would get back to you as soon as possible, but if you send me an email and I did not get back to you within like 2 days, it probably means that I missed your email. So feel free to resend your email. That's not a spam for me. All your email is never a spam. It just, if I don't reply, it means I didn't see the email. I'm sorry about that. It does happen. So if that happens to you and you need the answer, email me again, because sometimes I do miss it. And in this class, you're gonna learn a lot of new things. You're gonna learn a new language. You're gonna learn a new concepts. You're gonna learn that assignments do take time. If you haven't done so already in previous classes, welcome to MUIC CS program. It's fun. Yeah, we like to give a lot of assignments and hard quiz. But you learn a lot, right? So you're gonna be a really strong programmer, and this is basically you're gonna have to work hard for your hard-earned degree, right? But I promise you with this, right? The hard work you do is kind of we design it so that you can actually take it and actually adapt it to the future when you become a programmer, like a full-fledged programmer. Stop me if I'm going too fast, because sometimes I'm the type of person whenever I get excited, especially when I drink coffee, I go really fast. You can probably guess that I just had 3 shots of coffee before the lecture begin. Uh, so sometimes if I'm going too fast, let me know. And my last thing, please have fun, right? Don't make the class too serious. Joke around is fine. Joking around is fine. Joking around in the chat is fine. When I ask a question, uh, I just love to see response, right? And if you took a class with me before, you realize that I go into the tangential topic all the time that are involved in like anything related to the world of computer system, computer hardware, right? If you have questions that you're curious about, like how does this thing work, how does that thing work, I wouldn't mind if I know, right? I'm gonna expand it for you. So that's okay. We want to not just learn, we want to also have fun while we're learning. So hopefully that's a part of your goal, right? So make sure that's part of it, right? And lastly, this semester I am blessed actually with multiple TAs. So I would like to credit and thank them. Kristen, Sujina, and Justin and Nawat. These are the 4 TAs, and there's likely might be a few more. I would love to thank them because they're going to be helping me grading and make sure you get a feedback back whenever you submit the assignment as soon as possible. If you took a class with me before, you might have realized one of the downside of my class is I tend to not being able to grade the homework and assignment really quickly, right? It does take time whenever, especially when your code doesn't work, because I try my best to like give partial credit to try to understand what are you trying to do. So those things take time, right? So hopefully our great TAs can help you not just answering questions on Discord, but also like helping basically giving back the feedback to you as soon as possible. Uh, and the last thing before I transition to the lecture material, we have a server. It's called SysQ. It's kind of like a wordplay on our class name, System Skill. And if you take PCSA, you will know that SysQ is one of the interrupt that basically shut down the system. So again, it's a pun created by Ajahn Samsern. So you will have access to this server for this class as well as for the the PCSA class, the Principle of Computer System and Architecture, which is the follow-up class of this class. Both of these are the required classes for both for you to get the CS degree here. I hope you still enjoy at least these 2 classes and it expand into multiple computer system topics that if you're curious about, we can have special topics based on your interest in the future. All right. So let's get started. All right, let's get started about the things we supposed to learn in this class. Now that we cover all the admin stuff, right? Any questions on the management of the class? before we proceed onward? If you have any questions, and if I keep going, feel free to put in the question on the chat. I actually have the chat open on both my laptop right here and my desktop like right here. So if you see me actually looking at this direction, basically me checking the chat in case someone asking the question, right? The first thing I want to ask you is, what's a computer? Can someone tell me what's your take, I guess? What's your take on the word computer? What is it? Can someone tell me what is a computer to you? How would I categorize something as a computer? It's something that compute, right? That's a great answer. Why? Because the word actually has the word compute in them. One of the things that computer has to be capable of doing is computation, right? Computation. So then let me ask you this question. What's the difference between a calculator and a computer? It's actually, yeah, it's more fancy, but in what way? Like, why can't I just buy a tons of calculator and replace my computer with it? So it can be more complex, but fundamentally they compute things, right? How the computer is capable of other complex operation, right? So what do you mean by Oops, sorry. When you said complex operation, what does it mean? For example, right, can I, yeah, unless it's TI-84 or better, right? How many of you play games on your TI before your calculator, like your, I guess, fancy scientific calculator? Yes, no? But you answer you can play games on TI-84, but have you tried doing that before? Yeah, right. So what does involve with making them able to run a game? So you can compute other features, right? Why is that good? Why is a more complex thing? So first of all, you might have realized, right, when you said the word complex or finding new features or even game, right? It means that you can program, right? You can program because basically you can have a sequence of command and say do this followed by this followed by this followed by this when you run and take the input and produce this output, right? So you can program it take right it take user input, process the program, and do what after you finish processing? What does it give back to you? And yeah, there's a lot more possibility in what you can do on a computer because you can program, right? It produces an output. Yeah, exactly, right? So computer 101, right? The really, really basic kind of structure of a computer is you have the input devices. What are the input devices? Can someone tell me what are some of the example of these input devices? The keyboard, right? Or the mouse, right? What about the output? Your monitor, your printer. Yeah, that's awesome. This is like a new answer actually. The printer is one of the your output devices. You print something on a paper, right? What is the main memory? So let me ask you this question, right? Let's say you think of the processor, right? You want to compute things. How many of you have to do math with a scratch paper? You have to have like a piece of paper that write in equations because you can't just reach the answer in one step. How many of you do maths that way? I think everyone, right? Everyone need a piece of paper. Even the PhD in mathematics, they need their whiteboard. They need to write things, right? No one can finish computation in one step, right? Think of this scratch pad, uh, main memory, right? You all have heard when you buy a computer, it comes with a CPU and the memory, right? How big is the memory that you typically have nowadays for a computer or an iPhone or an Android phone? So what would be a typical size of the memory? Typically between 8 to 16, right? The more fancy ones would be 32. If you look at a server machine, it can be 256 or 512, right? These are the computer's splash pad. That's where you store the data. That's where you store the program, right? You notice how when you run way too many program on your laptop, what happened? If you have like 100 tabs on Google Chrome, what would happen? It slows down. Sometimes it crashes. Sometimes it hangs, right? It actually run out of the memory because the processor needs to use the memory. If your computer said one tab is enough, then I think you might need more RAM. Joking aside, Chrome Chrome consume a lot of memory, right? I agree. Chrome consume quite a bit of memory. What about hard disk? Where's your hard disk in here? Actually, I agree. Edge is not bad. At least the newer version of Edge. But where's the hard disk? Yep. Totally agree. And yeah, this is what I mean by like keeping the discussion going, right? I hope this is good because it allow you to, first of all, it means you wake up, right? And you participate in something relevant while it's not like boring and like stick to the slides. So let me ask you this question. How about hard disk or SSD? Where are they in this diagram? Is that a RAM? Can I use it to replace a RAM? Or is that what? Right? How about the incoming packets from your Ethernet port or when you send something to the server, right? The hard disk, the storage. That's a great comment, right? So there was a comment uh, that say virtual memory uses storage. Ex- uh, some part of the virtual memory would extend into the storage when you don't have enough memory. These are called paging. These are called paging. Um, and the SSD and hard drive, their main purposes is to store what? Is to store your file, right? That's actually not a part of the main memory, it's a storage. So when you think about it, essentially your computer, right? Your input devices, I need to click, yeah. Input device can be keyboard. And now I'm fighting with Microsoft PowerPoint. Stop fighting when I want to write things. Keyboard, mouse, right? You're also talking about SSD and hard drive. That those things can be interfaced through the main memory or through the processor. And processor would basically they use a scratch pad, right? So they basically use the main memory. The memory gives the data back, and the output, like your monitor. And again, it can be you write some file into the SSD, right, or the hard drive, or network, right, would be on the output. Sometimes we call this I/O. I/O means input and output, right? So this is kind of like a basic, super high level design of a computer. What about operating system? Have you seen this? What is this? Is the seems like we have a Microsoft fan here. It's one of the really good OS, actually. It's called Windows, right? How about this one? Any Apple fan here? So, to be precise, that's an expensive Unix. It's one of the Unix the distribution. How about this? With your characterization, I guess I would call this a cheap Linux. Uh, well, a free Linux. So you have the operating system, right? And what are these things? Have you seen something similar to this before? So it's kind of like a text-based uh command prompt slash terminal, right? That you can use to put in the command. I love this comment. Caveman OS. Yeah, I like that analogy, caveman OS. So these are another way you can interact with the system, right? It's still in the realm of operating system. It allows you to operate. As the name suggests, it's a system that allows you to operate the hardware, right? So conceptually, this is what happened. You buy a computer, right? What you get is a hardware. That's it. You buy a computer, what you get is a hardware. What do you need to make it run? You need the OS, right? And to be able to do more things than just what the OS can do, you install programs on it. Can be games, right? You install Steam and then buy games and install multiple games on them, right? And you keep using and playing those games, right? Uh, from the user point of view, if you look at this diagram, how many ways can you interact with your computer? There are generally two ways, right? You either use the program or use the OS, right? And that's typically how you use your computer. You either do something directly on Windows or you open a program like Chrome or like Dota 2 or any games that you downloaded on Steam. If you happen to buy like Cyberpunk on the day of release, instant regret, and then you kind of like disappoint before they fix the bugs, right? So these are things that you can do to actually use the computer, right? So either you go through the application program or go to the OS. Why is that the case, right? Pain, I would use that word because you don't have to use and control the hardware directly because that's going to be painful. You don't want to say, hey, open up the IO, make sure the IO send this thing over to this part of your main memory, make sure the CPU use that, make sure the CPU then spit out the output and put it in this location in the main memory, and then make sure another IO take that data, right? That's gonna involve a lot of pain. That's why the OS is there to kind of protect you from doing everything on your own to control the hardware, right? So that's conceptually what the OS is for. Sometimes it comes in a text format, as you've seen earlier, the caveman OS, right? Or sometimes you see the GUI, right? Graphic user interface format, which is earlier Windows 10, Mac OS, and Linux graphics user interface. And then you mentioned about expensive Linux, which is Mac OS, right? Not sure about the comments on that, but basically they are based on this thing called Unix. Anyone heard about this word before, Unix? So Unix basically are what we call multi-user, multitasking OS. Multi-user is self-explanatory. You buy a computer, many people can use it at the same time. Is that good? Yeah, why not, right? How many how many of you actually have like one or two computer for your entire family and everyone share that computer? Oh, you hit sharing, not after. Sorry, there was comments like not after my sister delete my save games. Uh-huh. Totally can understand the pain. Yeah, so but anyway, right? So you can have multiple people using your computer at the same time, right? If you buy a server, the system skill the our server is a prime example of that. When we go through in-class exercise, like multiple of you will be logging into the server at the same time and it would run. Basically it would give like do whatever you want them to do while servicing other user, right? This allow your computer to be cost efficient. You don't have to buy one server for one user, right? We don't have that much money. Multitasking. What does multitasking mean? What does it mean in just a typical like English word? It's doing more than one thing at a time, right? How many people run just one program at a time? Not many, right? Even when I play games, sometimes I have like YouTube opening up on the side while I'm like queuing up for a match in Dota 2, right? So multitasking allow you to run multiple programs on the OS at the same time. And there are variation of Unix, right? There are multiple versions like Source, AX, or Linux, right? Linux is nowadays like one of the most popular Linux version. And these are typically used in scientific or technical applications or cloud infrastructure or like IoT devices or PC or workstation, right? Basically, it is used everywhere and is available in many distribution. The word distribution means that I have Linux and I want to distribute it based on my way to package. There can be CentOS, Ubuntu, Fedora, and Debian, or many other. Right? Red Hat, for example, is like an old distribution of Linux uh, that has been around for a long time, right? Ubuntu also has been around for a long time. They have some differences across these distribution. Some of them would release the package that you can install sooner, while some other distribution would be like, hey, I'm gonna make sure I test the package and make sure that's bug free before the user can install. Some of them will be cater toward a production server or a server on the cloud where multiple people would be using the server. Some of them would be written by for the user, right? So a typical like user, you want to get Ubuntu and you install whatever package you want, and you basically kind of manage your own computer. You don't really share a computer with multiple people, right? So it depends on how they want to optimize certain parts of Linux. That would be the different distribution. And the other thing is the concept of the terminal, right? Sometimes we call this a terminal emulator or terminal application. What is an emulator? How many of you use an emulator to play PlayStation game or like a I don't know, Super Famicom game before? So for those of you who did before, what does the emulator do? It's a program, right? Where you install it on your computer and somehow it understands the program written for games for that particular piece of hardware, like PlayStation, for example, right? It doesn't it not it doesn't run different operating system, but it make the virtual hardware perfect. Yes, it's kind of like make this virtual hardware, virtual PlayStation by emulating the PlayStation. Basically, it's a program written in the language of your computer, and it allows you to emulate the language of the game, the PlayStation hardware. and that allow you to run, right? Basically, it's allow you to run the game built for the hardware, but on your computer. Terminal is a terminal emulator, right? It emulates the video from your display. This might look confusing, right? So I'm gonna use a figure to explain what the heck is a terminal. So here's your computer, right? Here's your computer that's from the earlier figure. Now, let's say I have a keyboard input and a display. And let's say this is not your computer, but this is your server. So for your system, SysQ server, anyone want to take a guess where is that located? So right now, where's the SysQ server? Definitely not at my home, right? It is somewhere on the MUIC campus, uh, right? So that's where the server is located. And with the lockdown, right? With the lockdown, can I actually go to the server, use the keyboard, and look at the display from the server? Can I do that? Not really, right? Well, yes, if I try and if I try to sneak in, I guess, and they were like, "Hey, the campus is closed. Why are you here?" Right? But would it be more convenient if I can access the server from here, from my home, like right here? Which is what we're gonna do in the second half of this class. It would be more convenient, right? But think about it. How can I how can I display things that are supposed to be displayed from the server on your computer? It's done through the terminal, right? So your own computer, you have your own keyboard and mouse, right? Your own display, basically your monitor. The terminal will allow, so this basically allow the server to give the output from the server's display onto your own display. It emulate the video terminal of the server. Basically, it emulates the server display, right? So any questions about terminal? Because one more thing, if you use Mac OS or Linux, you might have realized you can also use a terminal on your own computer. You can open a program, literally it's called terminal, and that allow you to put in things on a keyboard. It would display something on your own computer, right? And here are some sample of the how terminal looks, right? On Windows, there's a program called PuTTY. So if you are running using a Windows machine, make sure for this in-class exercise, download this program called PuTTY. We can use this to connect to the server, to the SysQ server. If you are using Mac OS or Linux, don't worry, the terminal is already built in for you. And here is how it looks on OS X, right? It'll be this black background, green text thing that you can type in the command and you can connect to another server. All right. Any questions about the terminal before we move on to what is the program and what's the process? Okay, so does it mean you have no internet? You can, yes. Well, you can use a terminal that connect to your own machine, right? If you don't have the internet, basically means that if you try to connect to the server, can I? No, because the connection is broken, right? So you can use still a terminal within your own machine, but you can connect to the server to use the servers. And the next thing I want to kind of cover is what's the program and what's the process, right? A program is just a sequence of binary data that contains machine instruction. It's a program. I mean, I think the program by the name itself is enough for you to understand what's a program. I think so. I think so. So in the earlier section, someone already used Windows Subsystem for Linux to use SSH and substitute that for PuTTY. So if you don't want to use PuTTY, you can use Windows Subsystem for Linux. So that's totally fine. I think it's totally fine. So let me go back to the lecture. The program versus process, right? A program, simple, is a program that someone has written, compiled into a binary and ready to run, right? Ready to be run by the user. For example, these are Chrome, right? Chrome is a program. A process is a running instance of a program. Basically, how many times you can open up the same program over and over? You can open up the Microsoft Word or Chrome, and then you can actually have multiple tabs on Chrome, right? These would generate different process and different threads. We are not going to talk about the concept of a thread yet, but think of a process is when a program get run, that instance of this running program is a process. It's a process. So it's unique to that just one run of the program. You can run the same program multiple times at the same time. Multiple version of the program get run at the same time. That's okay. Each instance of that is one process. And then you can pick which one are you gonna get rid of. You can kill different processes based on the ID, right? How many of you open up a task manager and see multiple instance of Chrome? Like Chrome, 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 Chrome. I guess yes, but you are basically telling some of your friends who said they have 50 tabs on Chrome a psychopath, which I'm not gonna make comments about that. I'll just make you to fight. I'm sorry, joking. Anyway, yeah, so I typically don't have that many tabs as well. I find it hard to track which one are which, right? So, but yeah, if you have multiple tabs on Chrome, some of these are a process, right? How many of you bring up a task manager and see like multiple Chrome before? So that is like an instance of a program, right? You have multiple times you run Chrome, and if you end one of the process, does the other get destroyed or like gone? It kind of depends, right? Sometimes if it's a parent process, it would kill the child process. But if it's two independent process, it won't kill the other, right? It's a different instance of the program. And yeah, so you two should fight. Sorry, there was another comment that says 17 tabs are rookie numbers. So I guess you two can fight and see who come out as a psychopath. I'm joking. Don't do that. Um. Anyway, so let's move on to the next thing. Before we're not gonna have time to cover your in-class exercise. Shell. What is a shell? It's a program. It's simply take your command, feed it to the OS. Simple, right? Take your command from the keyboard, feed it to the OS. Here's what shell is doing. That circle is what shell is doing. User type in the command. Hardware say, okay, OS say, okay, that's the command. I'm gonna run it based on your command. Run whatever is your command telling the OS to do, right? So this allows you to control the OS directly. So when you have multiple users, right, you can use, each one of you can use a different instance of the shell so that you can have multiple instances of way for each user to give the command to the OS. And now I'm gonna kind of combine shell and terminal together because terminal allow you to input the command. Shell allow you to feed the command to the OS. So if you look at locally, basically just your laptop or your desktop, right? I'm not talking about the server yet. the host OS, right? The host OS would have the shell that takes the command and feed it to the OS. And then it would talk to the terminal, because when you interact with the OS, which one are you talking to? Are you talking to the terminal, or are you interacting with the shell? Oh, so the language that you use for shell is uh there's like a specific command and syntax. We call this a shell script, and there's multiple version of shell, like a C shell, like bash, which stand for born again shell. Uh, different of one of these shell would kind of like have a different built-in command name, but it's kind of like similar. It's actually super similar enough that most of the time it's kind of C. Uh, yep. Uh, so that you can kind of basically use it interchangeably in most cases with some adaptation without too much of the learning curve, right? But from your point of view as a user, you basically interact with the terminal, and the terminal send the command to shell, and shell send the command to TOS. So how many of you are wondering that in this case, why can't I combine shell and terminal into one thing? Why can't I just link this box together? Right? Are you wondering that? So if you are wondering that, which is a totally legit question, right? If you see this figure, it's totally legit question to ask. But this make a difference when you have to connect to the server. So let's say this is your server, right? How do you feed the command to the server? It basically, the server will talk to the server's own shell, right? This is on the server side, right? It has its own OS and it has its own shell, right? Now, let me ask you this question. Do I have to use the same OS as the server to connect, I guess, to connect and use the server? Can I run things on Windows and connect to our Cisco server on that are basically running Ubuntu? The answer is yes, right? So let me ask you the second question. So here's your machine. Right? Let's say here's your machine. Where should the terminal be? Should the terminal be at the host OS, or is that on your own machine? It's on your own machine, right? Because that's where you interact. So that's where the human interaction happens. So the terminal is separate from the shell so that you can connect remotely. In that case, the terminal will send the command to shell, right? So any question before we wrap this up and kind of transition into the in-class exercise? So if you have questions, basically we're gonna transition to our first in-class exercise, and it should be really, really easy. You will connect to our system skill server. It's called sysskill.cs.muso.io. Musu. Uh, Port number 2222. I need to for sure I need to thank Ajahn Sansen again for his help in setting this up. So basically, MUIC has a IT, I guess the IT at Mahidol University has a really weird network requirement and setup. Basically, most of the time you cannot really log into things on campus if you're not on campus. Basically, Ajahn Sansen kind of helps set up this basically interface so that you can use the host name sysskill.cs.musu.io to connect uh, to the server using port 2222. Please follow on Canvas. You see in class exercise 1, there's a worksheet there. Your username on the worksheet, you see this thing, bracket username, right? Replace this whole thing with U followed by your student ID. So let's say your student ID is 521012. You'd replace username with u521012 because that's your username on our server. If if you already have an account on the server, use that old password. If you forgot your password, let me know what's your username so I can reset the password for you. All right. Now, basically, that's all for the lecture today. Let's swap over to Discord. Anyone here doesn't have the link to sign up for the Discord server? I'm gonna, yeah, I'm going through the Discord server right now so I can share the link. So this is basically the MUICCS server. Most of the discussion on all the class actually. There we'll do office hour on there. All of us like อาจารย์คณัฐอาจารย์ปิติอาจารย์สรรเสริญอาจารย์กฤษยา and many other people are kind of occasionally online here. Alumni are here. Many like job posting are all here. Definitely sign up and join that server, right? So we are gonna transition to Discord. Any last minute question on that we can kind of address on WebEx? Because otherwise I'm gonna be on WebEx on my laptop. No, if you never log in before, there should not be any should allow you to log in. If you hit enter, it doesn't allow you to log in. Let me know. I can reset the password for you.